Hello guys, this is Prime Concept. In this video, I want to explain a very important concept in physics. I want to look at the subject waves. I want to understand what waves is, and then I want to understand the effect on waves on our surrounding and even on us, right? Yes, so it's a very important concept. So you want to really understand what wave is and how waves works to make our staying here on earth effective, then stick with me in this video till the end and you'll get the concept. Now, I want to introduce waves. What are waves? Wave is actually a disturbance, is a disturbance that travels from one point in a medium to another point. So, wave generally is a disturbance that travels from one point of a medium to another point without a movement of the particles of the medium. So that is to say, when the disturbance travels, the particles of the medium don't travel along with the disturbance. The particles of the medium only vibrate about their main position, about a particular point. Now, you really want to understand this. Bring a rope, tie a rope to one end of a wall, tie another end to one end of a wall. So what you will do on that rope, mark a point, use a marker like this, mark a point on that rope, and then pluck the rope. You would notice that the rope would be vibrating. So what you have set up on that rope is what you know as what? Wave, a disturbance. You would notice that particular point you marked will be moving just up and down, up and down. So it will be moving about a particular main position, right? So this represents a particle of this rope. So while it vibrates about a main position, it doesn't travel, but you would notice that the disturbance you set up in this place will travel along the length of this rope. So that is wave. Is a movement of disturbance, right, from one point of a medium to another point without a movement, of course, of the particles of that medium. This disturbance that is set up, which is a wave, is actually carried by two entities, and the two entities that carry disturbance from one point to another point, both of them are energy and momentum. So these are the two mediums by which disturbance travel from one point to another. So that is wave. Now we want to quickly look at classification of wave. How do we classify waves? We can classify waves. I would classify waves into one based on their shape. So we can classify the different types of waves based on their shape. One is based on shape, and based on shape we can classify them into three. So one type of wave based on shape is what we know as plane wave. Another type of wave we can have is what we know as spherical wave. Then the third type of wave we can have based on its shape is what we know as harmonic wave, right? We'll be looking at this type of waves when we start talking about types of wave and the examples. We'll see how these waves are formed, right? You can clearly see the spherical wave in water. If you bring stone and release a stone on a still water, you notice a spherical pattern that is formed in that water. That is spherical wave. And if you allow that to travel far, you will notice that at a great distance, it will no longer look spherical. It will now begin to look plane. You understand? So then number two classification for wave is based on their audibility. Based on audibility. That is to say whether it can be heard. When you say something is audible, it means that that thing can be heard. So we are classifying wave based on whether you can hear the sound, so how audible it is. So based on audibility, we can also classify waves into three. We can classify them into three. So number one is what we know as audio wave. Audio wave. So when you say audio waves are waves that are audible. You can still call them audible waves. So they are waves that are audible to human hearing. So when I say be audible when you're talking, when you talk, you're actually producing a wave. That kind of wave you produce is sound wave, right? So when I say be audible, I'm not saying shout. I'm just saying talk so I can hear you. So audible audio wave is a wave that is audible to human hearing. So number two is what we know as infrasonic. Infrasonic wave. Infrasonic. So infrasonic wave is a wave that is below human hearing, right? Now there's something we call threshold of hearing. Threshold of hearing would learn later spans between two values, two frequency values. So if you go below the threshold, you strain your ears just to hear somebody and you won't be very comfortable because you can't hear the person very clearly. So infrasonic waves are waves that are below what humans can hear, right? So it means if you try to hear infrasonic sounds, your eardrums will be affected. It won't be very comfortable because you strain just so you can hear. It is below human hearing. Then number three types. Number three type is what we know as ultrasonic. Ultrasonic wave. Ultrasonic wave is a wave that is beyond human hearing. So this is what they use in ultrasound, right? Yes, for radiographers, they use ultrasound to check maybe bones, whether bones are still in place in human body. So ultrasound is a wave that is beyond human hearing. So when you try to hear, it might burst your eardrum. So ultrasound. So these are the classifications of waves based on shape and based on what? Audibility. So we also want to look at types of waves that we can have now. Types of wave. So we have two main types of wave. Number one is mechanical wave. Mechanical wave. That's number one type of waves. Now, what are mechanical waves? Mechanical waves are waves that require material medium for their propagation. Waves that would require a material so that they can travel. Those kinds of waves are what we know as what? Mechanical waves, right? What are examples of mechanical waves? Example of mechanical waves would involve sound wave. A good example is, say, in your churches, right? Now, when your pastor is preaching, most of the time, so that those that are far can hear him clearly, he uses a microphone. And that microphone is linked through an amplifier to a speaker. Now, you notice that when he produces sound, it will go through the speaker, and the speaker has a kind of skin, an elastic skin. So the sound propagates through that speaker, the elastic skin of that speaker, right? So that is an example of a mechanical wave that requires material medium for its propagation. Another example would include wave on a string. So you still go to the church, you see those that play the guitar in the church, they pluck it. So that kind of wave is also what? A mechanical wave. Waves on ropes are also examples of mechanical waves. Water wave is also an example of mechanical waves. So waves that would require materials so that they can travel, those kinds of waves are mechanical waves. Number two type of wave we have, because we have two types. Number two, we say it is non-mechanical. Non-mechanical waves, or we can still call them electromagnetic radiations. Electromagnetic radiation. So we have non-mechanical wave, which can also be called electromagnetic radiation. So non-mechanical or electromagnetic radiations are waves that do not require material medium for their propagation. That is to say, they can travel in free space. For example, a very good and simple example is the sun. The light of the sun gets to you in vacuum. It doesn't require a material. There is no, say, a pipe or whatever means through which the sun travels. It travels in free space. So, and a good example of an electromagnetic wave is light wave. Light wave is an electromagnetic wave. All the electromagnetic spectrum, they are all examples of electromagnetic waves. So examples include light. Electromagnetic spectrum is light actually, but let's just mention them. You have the cosmic radiation. You have the cosmic radiation, right? Which is the radiation with the smallest wavelength. Then we have gamma radiation. We have X-ray. We have ultraviolet radiation. We have the infrared. We have the visible light. We have the infrared. We have the infrared radiation. We have the microwave. We have the microwave. We have the radio, which is also known as TV radiation. So these are examples of electromagnetic or non-mechanical waves. So all these radiations, they do not require material medium, right? And very quickly you would understand that I've written this in order of what? They are increasing wavelength or decreasing frequency. So these are the two types of waves that we have: the mechanical wave and the non-mechanical wave. I'll stop this video at this point so it won't be too long. In my next video, I'll be introducing what we know as wave motion. The wave motion describes the movement of the wave itself and the particles of the medium. So we want to look at wave motion in our next video. So do well to subscribe to my channel so that you can get the video that comes after this. Thanks for watching. This is Prime Concept. Thank you.